Hi guys, you are welcome once again to the Smart Way lectures on the Science Ambassador series. This is a series of lectures we are running on all the areas in science. That is the elective chemistry, the elective physics, the elective biology, and the integrated science. Today we are here with you to take one of the main standing topic in chemistry called thermochemistry. Thermochemistry, otherwise also called the energy and energy changes. So today we are going to take this topic, delve deep into it, and bring out all the concepts and the relevant facts that you need to understand before your exams. So when we say thermochemistry, what do we mean by thermochemistry? Very simple. It comprises of two words, and we can divide the word into two so that we can understand it very well. Thermochemistry. Okay, thermochemistry. Now, the word thermo, okay, it comes from a Latin word, and this means heat. Okay, and we know that in chemistry simply means chemical. Chemistry simply means chemical. Okay, chemistry talks about chemical reactions. Talks about chemical reactions and properties. Chemical reactions and properties. So when we consider these two words, thermochemistry, we can see that we have thermo means heat and this means chemical reaction. It means basically that we are going to study the heat that is associated with chemical reactions. That is the meaning. We are going to study the heat that is associated with chemical reactions. Not even chemical reactions. Basically, we see a lot of things occurring around us. For example, we see these processes like one, boiling of water. We see processes like melting of ice. Now we see processes like, say, burning of paper, and even lighting of matches. So lighting or lighting a matchstick. Lighting of matchstick. Now we see these processes almost every day in our life, accompanied by some form of energy. It either requires or give out some form of energy. Boiling of water, for example, you need energy to boil water. You need heat to boil the water. In melting of ice also needs some amount of energy to melt. Okay, and also we have burning of paper. It needs some amount of energy. That also need amount of energy. Now, the study of the energy changes, the study of the energy required or involved in these processes, the study of energy involved in these processes is what we call thermochemistry. And so basically processes are both physical. So this, for example, processes are both physical, Okay, we have both physical processes that are accompanied by energy, physical processes that are accompanied by energy, and we also have chemical processes that are also accompanied by energy. Okay, they are all accompanied by energy, chemical processes. Now, the study of the energy changes associated with both chemical and physical process is what we call thermochemistry. And so, for example, boiling of water is a physical process. It is not a chemical reaction. Boiling of water is not a chemical reaction. Chemical reaction involve breaking down of what? Interatomic bonds. So chemical reaction, chemical processes involve breaking of interatomic bond, involve breaking of interatomic bond. It involves breaking of interatomic what? It involves breaking of interatomic bond. And physical process involve breaking of intermolecular bond. So when you watch our video on breaking of intermolecular bond. So when you watch our video on chemical and physical bond, you will see that we have divided reactions according to physical and chemical processes. We have divided bonds into two: physical bond and chemical bond. And so processes in chemistry are usually accompanied by energy, and these processes are physical and chemical. Physical process involves separating of molecules, breaking down of molecules, and chemical process involve breaking down of atoms, that is, breaking down of the bonds between atoms. And so all these, because we are breaking down some bond within atom. For example, if I put sodium chloride in water, okay, or otherwise if I burn paper, okay, what am I trying to do? I'm trying to break one atom from the other. So I'm trying to break one atom. So one atom, I'm trying to break atoms, okay, away from what? Another atom. Okay, that is that. And here, physical process, I'm trying to break what? Molecule. I'm trying to break molecule, okay, from another what? Molecule. And this is what we call a physical process. And because you are breaking the bond between molecule, you require some amount of what? Energy. Because you are breaking the bond between atoms, you require some amount of energy. The energy that involved in breaking down of either interatomic and intermolecular bond in chemical and physical process, okay, the study of this energy accompanied by chemical or physical reactions is what we call the thermochemistry. And so this, for example, is the two of them is a physical process. The two of them here we have here is a physical process. Boiling and what? Boiling of water and mass is a physical process. In that physical process, what happened? Energy is supplied to physical process. Energy is supplied to what? To separate molecules of what? Water. Okay? To separate molecules of water. For boiling, for example, molecules of water are separated. Have you gotten that? Boiling is just separating the molecules of water. So you have water, okay, in a bowl that you are heating. So that you are supplying energy to it, heat to it. And basically what happened is that we are separating one A2O, okay, from another A2O, okay, and this is what we call a physical process. And melting to is the same, and boiling and melting to is the same. Now the heat accompanied by breaking down of this bond is, okay, what we study, the study of it is what we call thermochemistry. And lightning is also the same. When you light a matches, what happened? The friction produced between the matches head and the box creates some form of energy which comes as in the form of light, and then chemicals react within the matches box and then between the matches box and then the matches head that will generate energy. All these processes, okay, the two of them is a chemical process. Burning of a paper is a chemical process. Because it involves breaking down of what? Interatomic bond, breaking down of what? Bonds between atoms. So it's a chemical process, okay. And so the energy that is accompanied by breaking down of this bond, that is accompanied by this reaction, the study of this energy is what we call thermochemistry. The study of this energy is what we call thermochemistry. And so therefore we can have there are various or numerous, okay, we can have there are various processes that we can associate them with them. Okay, we can give so many chemical reactions. Now I want you to know that all these energies that we are talking about, the study or the change in the energy, some of them are obvious, some of them are very huge. We can really measure it with a thermometer. Some of them are also very silent energy. And so what it means is that some of the energy, okay, that are involved in chemical reactions are notable, are very obvious, and are large, that we can measure them directly with what? With instrument. Some of them too are very, very small that we cannot measure with instrument. Okay, for example, if I pour normal salt in water, like dissolved salt in water, okay, so if I pour salt in water, okay, so if I pour salt in water, for instance, salt in what? In water. If I put salt in water, now you can see that the salt, that is the salt, is going to break down, the salt is going to break down the water, and the water is going to break down the salt. And so you can see this in the bowl. The salt enters, and when it enters the water, what happens? It's going to break into what? Into ions. We are going to get this one plus, and then we are going to get this one what? Minus. So the salt is going to break down. The sodium chloride salt is going to break down in the water. But when you put a thermometer inside, that we are recording, the thermometer will not be able to what? The thermometer will not be able to sense the energy that was used to break down the what? The sodium chloride. Okay, the sodium chloride is a salt. When it gets into water, some amount of energy, okay, was required to break down the sodium chloride. But if you want to measure the energy, put the thermometer inside. So this is a thermometer, just to check whether there is energy. Okay, thermometer. So there is a thermometer, and so the thermometer will check whether, okay, some amount of energy was involved in the reaction. And so what basically happened is that for sodium chloride to dissolve in water, the energy, okay, change is very, very, very small, that you can't notice that energy. So some chemical reactions or physical reactions, okay, are accompanied by energies that are very silent or are not notable, okay, and there's means by which what we find them out. So that is what we say thermochemistry. So thermochemistry is the study of the energy changes or involved in what? In both chemical and physical reactions. Have you gotten that? The energy changes as a result of either you are breaking some interatomic bonds, or breaking intermolecular bonds, or you are forming them. That is where it comes from. Again, according to energy changes in reactions, there are two types of what? Chemical reactions, or there are two types of thermochemical reactions. So according to energy changes in reactions, there are two types. So I want you to, let's go to the types of chemical reactions, in terms of types of chemical reactions according to energy changes. Okay, so types of chemical reaction, or let's simply write types of thermochemical reaction. So we are going to get types of what? Thermochemical reaction. Types of thermochemical reaction. Reactions. Now what we are saying is that energy is evolved in chemical reactions and physical reaction. Now if you want to break bond, you need some amount of energy to break bond. If you want to form bond, you need some amount of energy will come after the bond is formed. What basically happens is that when you light a matches, when you are burning your gas in your gas cylinders, you would see that there is a huge amount of energy that will come out from the process. Like for example, you are boiling water. Okay, let's also take an example that you are boiling water. You need an energy to boil the water. The water have to absorb some energy in order to be heated. And when you are also cooling the hot water down, the energy is given out to the surrounding. And so it means that in reactions, okay, energy comes or goes in two ways. Energy comes or goes in two ways. The first one is, in one reaction we can have some energy coming out. Have you gotten that? So in one reaction you can have some energy coming out from the reaction, and this type of reaction is what we call exothermic reaction. That's what we call exothermic reaction. Thermic what? Reaction. This reaction is called exothermic reaction. That is, and the reaction, there's also another reaction called endothermic reaction. Endothermic reaction. Endothermic reaction. So there are two types of reaction based on energy changes. So based on energy changes, it's either when you are performing the reaction, you will get huge sum of energy liberated to the surrounding. Just like you are burning what? Paper. Okay, like you are burning paper or you are burning a gas. Okay, burning what? Paper, or you are burning a gas. Okay, burning paper. What you see that, okay, when you use the matches to light up the paper, the matches, the energy that you start with is very small, but at the end of the day the paper will burn and produce large amount of energy to the surrounding. Have you gotten that? And so you can see that in some reactions energy comes out from the reaction to the outside. This reaction is exothermic reaction. So the study of energy changes in chemical reactions are studied based on types of reactions. Reactions that evolve or liberate or produce heat to the surrounding. Reaction that produce heat to the surrounding, that is, for example, like the burning of the paper. Okay, the burning of the paper, or when you are even cooling down hot water. Okay, if you have hot water in the flask or in the beaker, you have hot water. So you have this, you have hot water here. Okay, and you are cooling it down. Okay, you are cooling it down. What happens? With time, you will see that energy will come out from the what? Heat will come out. That is, heat will come out from the flask. Or heat, okay, will come out from the flask in all directions. What is happening? Energy is going outside. Have you gotten that? Energy is coming outside, and that kind of reaction is what we call the exothermic reaction, where energy comes, leave, okay, leave the reaction and come outside, like the burning of the paper, where excess energy is liberated to the surrounding. That is what we call exothermic reaction. So the thermochemistry is studied according to that line. And we also have what we call endothermic reaction. In endothermic reaction, basically what happens is that, okay, energy is absorbed into the reaction. Energy goes into the reaction. Energy is taken into the reaction. Energy is taken into the reaction. Normally, when we go on, you understand why energy is taken to the reaction. I just explained to you that energy is going to be used to what? To break down the bonds. And so some of the reaction require much energy to break down the bonds in them. And so therefore, the energy sometimes go into the reaction instead of coming out as what? Heat. It goes into the reaction and is absorbed into the system. There are so many reactions that are accompanied by that. In our next lecture, we will talk more about exothermic and endothermic reaction, and we would be able to give our associates some typical reactions that are associated with that. But generally, these are the types of a thermochemical reaction. That is, reactions that evolve what? Energy. Okay, that evolve energy. They are divided into two: exothermic reaction and endothermic reaction. A clear example of endothermic reaction is when you are what? Heating water. Okay, when you are boiling water. When you are boiling water. Now, when you are boiling water, what happened? The water was originally cool, The water was originally cool, but before the water begins to boil, okay, you need to supply some amount of energy into the water. So the water will have to absorb the energy from the outside. The water will have to absorb energy into the water. That is what we call endothermic reaction. And so in endothermic reaction, energy is absorbed into the reaction. Energy is taken from the outside and it goes into the what? Into the what? Into the system or into the reaction. That's what we call endothermic reaction. There are so many reactions that are accompanied by that, and I'll give you some few examples, and in our next lecture I'll give you many of them. Okay, so let me quickly give you some examples of endothermic and exothermic reactions. Okay, let me quickly give you that and then we end the lecture. So quickly let's look at some specific examples of exothermic and endothermic reactions so that we end the lecture. So examples. Now, under exothermic reaction, we have a lot of them, but I want to tell you that most reactions are exothermic. Almost about 90% of chemical reactions are exothermic reactions. So I want you to know that. So most of the reactions that you can give, normally most of them are exothermic reactions. Okay, so examples of exothermic reaction. Okay, we have what we call one, combustion reaction. That is the burning. Combustion reaction is one example. That is the burning. Okay, combustion reaction is one. Bracket the burning. Okay, and oxygen. Now there's also another example, that is the neutralization reaction. The neutralization reaction is also another a good example of that neutralization reaction. That is between an acid and a base. Neutralization reaction. Most of them are exothermic reaction. That means they evolve heat to the surrounding. They give out heat to the surrounding. And then we also have what we call the formation reaction. That is a formation of what? A compound. So formation reaction is one. We have a lot of them. Okay, we have what we call the respiration is also another example, which is also combustion reaction, but let me write it respiration. It's also another example. We have a lot of examples of exothermic reaction. Okay, we have a lot of examples. Some decomposition reactions are that. Let me give an example of that. Let me give other examples like the cooling of what? The cooling of water. This is not a chemical reaction, but I'm just adding one of the physical reactions to it. Cooling of what? Of water. Okay, cooling of water. Okay, these are physical. And then we have so cooling of water. So cooling of water is fine. So quickly let's look at endothermic reaction. Endothermic reaction. Examples of endothermic reaction is one, we have the heating of water. The heating of water requires some amount of energy. Heating of what? Of water. The water have to take up the energy from outside. That is one. We have what we call the dissolution. The dissolution of, that is dissolving this salt in water. Dissolution of ammonium chloride or ammonium chloride or ammonium nitrate. Okay, when you pour this salt in water, the water, okay, become cool. Okay, the salt absorb energy from the water and the water become cool. Okay, that is one. And a good example of what? Exothermic and endothermic reaction. We also have some decomposition reactions. Some decomposition reactions are example. Decomposition reactions like the calcium carbonate. Okay, when you decompose this one, you see that there is a condensation. there's a condensation. It's also a good example of that. And we also have the dissolution of the anhydrous copper 2 tetraosulfate 6. So the dissolution of what, when you pour this in water, anhydrous copper 2 tetraosulfate 6. So these are examples. So I just want to give you examples so that in our next lecture in our next 2 lectures we'll go deep into these examples. Now we'll end the lesson here, and in our next episode we'll be looking at how to physically and practically measure the energy changes in these things, which is calorimetry. We will look at practically how we measure, what kind of instruments and what calculations we do under this. So I'll leave you here, and in our next episode we'll do that. Thank you.
My level up.
It's back.
Maybe today I don't get nothing, but tomorrow I go get something. And I go buy the motor for mama. But the enemy won't worry me. I go show all of them tragedy. No be today, we start to. So if I sing my song, if I keep up for long, because you don't know that day, Jesus Christ.